Hello student, this is the question number 8 of this PYQ series of JEE Advanced 2024 of Organic Chemistry, and this is the last question and last and best question. The question is an organic compound P with molecular formula C9H18O2. First of that, this question is a lengthy question. This question has 12 marks and has 2 sub question. Let question is that an organic compound P with molecular formula C9H18O2 decolorizes bromine water and also shows the iodoform test. P on ozonolysis followed by treatment with H2O2 gives Q and R, while compound Q shows positive iodoform test. Compound R does not give positive iodoform test. Q and R on oxidation with pyridium chlorochromate, that is PCC, followed by heating gives S and T respectively. Both S and T show positive iodoform test. Then complete polymerization of 500 moles of Q and 500 moles of R gives 1 mole of single acyclic copolymer U. Then given that atomic masses of hydrogen, chlorine and oxygen. Then the sub question first is sum of number of oxygen atoms in S and T, and second one is molecular weight of U. First, read carefully all the question. This question is little much hard. So first read an organic compound P with molecular formula C9H18O2. I am writing here molecular formula C9H18O2. I already told you in the previous question, if you have given any molecular formula, any compound of molecular formula, then first find out the double bond equivalent of that compound. So double bond equivalent, what is the formula? Half into 2C minus number of hydrogen plus number of nitrogen. Oxygen is not involved in double bond equivalent. So what will, and plus 1 is there. I always forget this. Plus 1 in the bracket. I am writing again here. Half 2C minus H plus N plus 1. So what will come? Half into 2 into how many number? 9 minus H 18 plus 0 plus 1. I again forget that plus 1. So what will come? 9 into 2, 18 minus 18 plus 1. And this plus 1 is outside that. Sorry. This plus 1 is outside that half bracket. So this will become 0 plus, that is 1. 1 double bond equivalent comes out, means there should be 1 double bond in that chemical formula structure. It decolorizes in what is next given that it decolorizes bromine water and also shows positive iodoform test. So if you know that bromine water decolorizes bromine water, which decolorizes bromine water? If the compound has double bond alkene. If you react with bromine, simply addition reaction is happening. Bromine is added, and if this bromine has a addition of Br2 in alkene gives 1 to here dibromo product. So how can this determines its original color of that bromine solution has red brown color. After reaction with this alkene, it decolorizes. So from that we can say that here alkene is there. So here is also mentioned that it P decolorizes bromine water, that is 1 double bond should be there, and also after finding double bond equivalent 1 double bond is there. That means here alkene should be there, not any carbonyl group like oxygen C, because here all two oxygens are there. This should not be there in formula. Our double bond should be in alkene. So next what they said, so that positive iodoform test. So which compound gives positive iodoform test? Acetyl group. Generally what is acetyl? C double bond O. If any compound has this group, then it's a positive iodoform test. First, what is iodoform test? Let's see. This is the compound is reacted with I2 and NaOH. So first what is happening is this OH minus takes that, this OH minus takes out that proton, and CH2 minus C double bond O R, this is equal to there, he is opening, this is opening. So CH2 double bond O minus R. After that I2 is there, I, this comes back, this is attack on in that, and I plus is removed out. So what is happening? CH2 here I, here double bond and R. Similarly again OH minus comes, take this proton, OH minus come, take this proton, again this attack on iodine, and this is replaced by iodine. Again next again OH comes, third proton removed out, and finally what is formula? Finally what? Ci3 here R. Again base is there, OH minus. Now here is no any acidic proton, this is attacking on that carbonyl carbon as a nucleophile, this bonds open. So what is happening? I3C O minus R OH, here O minus is there, this comes back, and Ci3 minus removes, Ci3 minus plus what is here? Acid is forming. So here acidic proton is there and Ci3 minus is there. So here what is happening? This base takes that acidic proton and here form, here counter ion Na plus is there. So what is forming? Here double bond O, here R, here O minus Na plus plus CHI3, CHI3, this forms. And so here from you conclude that any acetyl group gives positive iodoform test. So but here if you see here in the formula, here if we make acetyl group in the given structure, then C double bond O, here double bond comes out, and it will not give decoloration of bromine. So this group should not be there, and here is only one double bond equivalent there. So this group should not be in our compound. Then what will happen? Again if any secondary alcohol like CH3, here CH2OH, here what will be R, if this type of group is also there, then it can also give positive iodoform test. Here firstly happening is that this is converted to, by first oxidation of that secondary alcohol is happening, and this is converted to CH3 double bond O R, converted to this, and this acetyl group gives iodoform test. So here firstly what happen? Oxidation of secondary alcohol. So means here if this group is also present, then it can also give positive iodoform test. So now here if you see here 9 protons, 9 carbons are there. First draw 9 carbon, 1 2 3 4 5 6 7 8 9. So here our one group should be like that. So I am writing here CH3, here CH2, and here one OH. One group is formed that. Then what about the next? One oxygen is also consumed there. Next, they said that positive addition after the P on ozonolysis followed by treatment with H2O gives Q and R. P on ozonolysis means here one double bond should be there. Like suppose here any whatever here it will be, here maybe here and so on. After ozonolysis, it gives, if reductive ozonolysis gives, then it will give aldehyde. But here in question mentioned that ozonolysis followed by treatment with H2O. That means again oxidation of that is happening and gives acid. Acid is formed to acid. So means here this type of alkene should be there. Again gives Q and R. While compound Q shows positive iodoform test. If you see, suppose this is our Q, this is R. Q should give positive iodoform test. Means here what should be there? Here should be CH3 there. Means our structure of Q should be like that. Here obviously acid does not give positive iodoform test. Means if you see here, our acid should be there. Now here suppose here CH2 CH3, suppose our this group is there. If OH should not be there, because so our one secondary OH should be there. Like suppose OH is there, here CH3, this group should be there in Q, in our Q. Between this, how many carbon we cannot predict by this. So next, what are they given that while Q shows positive iodoform test, compound R does not give positive iodoform test. Means in R, suppose here R is there, here no any secondary alcohol group should be there. Means ours is, it should be like that. So if you see here, this is comes from our double bond, this is comes from our double bond, means remaining part is our in main structure. So if you see here, one OH is here, one OH is there, two oxygen in molecular formula, they are consumed here. So here our Q should be at the one of the end, because CH3 should be there. Here CH3, here CH2, again here CH2. Now again one problem comes that how many CH2 should be between that OH and the carbonyl group. So again read next. R does not give positive iodoform test here. Then Q and R on oxidation with pyridinium, that is PCC, followed by heating gives S and T respectively. Let's suppose here now here if you see here, the question said that Q and R on oxidation, means oxidation of benzoic acid is not possible. Therefore one OH should be there, that like that, where it is should not have like that secondary, but CH group is not transition there, means OH group is in between there. So OH should be there. Our R is like this. So after oxidation by PCC, what will happen? This secondary alcohol will convert to ketone. Suppose this will form again here. Suppose this is formed. So in the next, read again. Oxidation followed by heating gives S and T respectively. Both S and T show positive iodoform test. So then again here, followed by heating gives S and T respectively. Both S and T give positive. From this word is important here. Heating. If you see here, both yes and T give positive iodopalm test. If you see here, this will give positive iodopalm test, but this will not give. This is suppose this is our here, this is our T, but this T will not give positive iodopalm test. Then what should be there? If you read carefully, heating is there. It is beta keto carboxylic acid. This is also suppose beta keto carboxylic acid. Suppose I am saying suppose we are not confirmed that how many CH2 group in between beta ketone and carboxylic group. So after heating, decarboxylation should be there. If only when beta ketone group is there. Therefore after decarboxylation, CH3 double bond O CH3. Here also after decarboxylation, here CH3. Now you can see this give positive iodopalm test, this will give also positive iodopalm test. So this is our S and this is our T. Now from this all information, put this in here. So our S should be what? Go backward. This is our S, then previous one, this is our this, that previous one this, and before that what will happen? Suppose I am writing again here Q. Our Q is CH3 OH, here one carbon, and again here double bond is there. But this carbon is has not a this carbon is not of Q. So this is our part of Q from that structure. So where it can match? Here. So CH3, here CH3 OH, the double bond should be after 1 2 3 4 carbon atom, 1 2 3 4, and here our double bond should be. So this is formed. Then next our R is this. So we not confirm that how many carbon are there, but we confirm that this much number of carbon atom in R. How many? 1 2 3 are confirmed, and this is start from here. So because this is comes from double bond, so this is should be like OH 1 2 3 1 2 3 R, and this double bond is of not part of R. So put this in here. Here double bond is there. After C, this carbon is here. After this one CH2 is there, and after this one OH is there, and this water will be there. So from there, now all information complete from the question. So now fill all the valency of carbon by hydrogen. CH2 here, one CH, CH, CH2, CH, here CH2, CH3. Now to confirm their structure, count number of carbon are 9, obviously, number of oxygen 2. Now count number of hydrogen 3, 3, 6, 3, 9, 3, 3, 6, 3, 9, 3, 12. Here 12 to 13 to 15, 3, 18, means see here 18 hydrogen are there, means this is the our structure of P which we required. So from that we can find out the answer of first sub question. Sum of number of oxygen atom in S and T is. From that we can find out the structure of S and T. How many number? Yes, there is 1, and T also there is 1. Therefore answer should be 2 of our first question. Now let's see second question. What is here? Again one information is complete polymerization of 500 moles of Q and 500 moles of R gives 1 mole of a single acyclic compound U. Molecular weight of U is. So what is our Q and R? What is our Q? This, and R. So from their structure, what will be the structure of R? See here, if this is, from this can we find out. this carbon is this, means here which one, this one is. So here CH, CH2, OH, CH2, CH3. So our R should be this. In R, how many CH3 will be should be there? After COH, CH2, CH3, CH2, CH3 means right. It is right. CH2, CH. This should be our R. So again, write neatly the structure of Q and R. Here Q is CH3, OH, double one O, OH. This is our S. Sorry, this is our Q. And R is here, this one, OH. This is our R. So in question, complete copolymerization of 500 moles of Q and 500 moles of R. 500 moles of Q and 500 moles of R. Polymerization of this group U. So if you see here how polymerization is happening, this acid is group here, this is alcoholic group is there, and from esterification form, that is esterification form, and one water molecule from combination of two molecules form. So I am writing here, suppose this is our Q, OH remains here, double bond O, this alcohol and OH from this, OH from alcohol and H from acid come here. So here O, and it is connected with that carbon. So 1 2 1 2 here, 1 2 1 2 here, double bond O, here OH. So next, again this one has carboxylic group. So what will happen? Again another molecule of S will come, and this will form ester with that, and one water molecule will remove out. Again, how many molecules are there now? 1, 2 and 3. From 3, 2 water molecules. Again here one OH is there. Again out of R will come. This will react with that, and one water molecule will leaves out. So now total how many molecules becomes? 1, 2, here 3, here 4. 4 water molecules and 3 H2O molecules remove out. So if you see here total number of molecules 500 plus 500,000. So from you conclude that if 3 molecules are there, 2 water molecules. If 4 molecules are there, 3 water molecule will be left. So similarly, total 1000 molecules are there. Therefore 999 water molecules will be removed out. So from that, we have to find the molecular weight of U. From all these 500,000 molecules, U polymer is formed. What is the molecular weight should be there? Means first find out the molecular weight of Q plus molecular weight of R into 500, because each has 500 moles, and minus how many number of water molecules? 999. So now it becomes only mathematics. First calculate the molecular weight of this. How much become? How many carbon? 1 2 3 4 carbons. 1 2 3 4. 4 into 12 plus how many hydrogen? 3 4 5 to 7 7 1 1 7 plus 1 8 plus. Now how many oxygen? 1 2 3 3 into 16. So what will 8 8 24 2 10 104 molecular weight of Q. Similarly, what will be the molecular weight of R? 1 2 3 4 5. 12 into 5 60. Now how many hydrogen? 3 to 5 6 7 to 9, 10. 3 oxygen, 48, 8, 11. So now, so the total molecular weight of 500 moles of Q should be 104 into 500. Total number of moles of R should be 118 into 500. And after polymerization, these all molecules combine and form polymer. So 104 into 500 comes out 1,11,000. From here 118 into 500 comes, sorry, to make simply that is 50,000 comes from that. From here 20,0495, this much, 1,11,000 total molecular weight. But this is not a molecular weight of you, because 999 water molecules removed out. Means what is the total molecular weight of water molecule? Water molecule has a 18 molecular weight. If we multiply this, how much comes with that? 17,980. If we minus that 17,980, so how much will come? Sorry, here 2 is there. So 1039. This is our, if you minus total molecular weight of water molecules from the total molecular weight of Q plus R of 500 moles, 1000, then this much gram per mole of molecular weight of U should become. So our correct option should be 93,018. This is the molecular weight of U. This is the answer of second sub question, and answer of first question sub question is to total number of oxygen atom in Q and R. Sorry, S and T. So this is the so much lengthy question, and yeah, question has also number on 12 marks, and this question will take so much time of your, and this is little much hard also. So I hope guys you have well understand answer of that question, and this is the last question of JEE Advanced 2024 of organic chemistry. I will continue next, whatever it will come in mind in the next video. Thank you guys.